So now we're going to be looking at some chain rule problems. And chain rule is a really powerful tool to allow you to do all kinds of derivatives. And it's probably the one more complicated rules. But see, without the chain rule on this derivative, I would have to expand this out to the 10th power, right? And that would be pretty obnoxious. Or I'd have to do a product rule with 10 multiplications, right? So the chain rule is I look at the outer function. I'm peeling a layer. So the outer function is the 10th power. So first I apply power rule. It's going to be 10 times the inside. Like, I don't touch the inside when I apply any particular rule. I leave the inside alone. So that's power rule. I brought the 10 down. I subtracted 1. And then because the inside, this is what I tell myself, because the inside is not x, I multiply by the derivative of the inside. The derivative of the inside would be the derivative of this, which would be 12x squared minus 1. And that would be it. How about this one? Here the outer function is cubing, so when I take the derivative, I'm going to do 3, leave the inside alone. And then after I've done the power rule, I take the derivative of the inside, because the inside is not theta in this case. Derivative of sine is cosine theta. The derivative of cosine is minus sine theta, negative sine theta. Okay. Here, the outer function is power rule, so I'm going to do, because it's something cubed, I'm going to do outside, do power rule. Then the inside is not x, so I got to take the derivative of the inside. Derivative of ln of x is 1 over x, and the derivative of x squared is 2x. Right? Like that. Thanks for watching. If you're looking for more examples, go to my website. In there, I have free access to over 400 calculus questions that I solve and I show you step by step. So if you're interested in seeing more, please check out my website.